Hi, I'm Sarah Tyke, host of the Interested Reader podcast. Each week I'll bring you a short lesson in physics or astronomy, followed by a brief overview of what's happening out there in the universe. We'll also merge the wonders of science with the depths of spirit and discuss the metaphysical and spiritual aspects of our universe and ourselves. Come with me as we explore stars and souls, the intersection of science and spirit. Hi everyone, welcome to the Interested Reader podcast. I am your host Sarah Tyke, and today we are going to be talking about magnetism, which is one of my favorite topics. And as I was preparing this, I kind of realized that I'm probably doing this a little out of order because usually we talk about electricity first and then magnetism. And I know we haven't really done a lot of stuff with electricity. We've talked about the nature of light, but we're just going to jump ahead to magnetism. So let's just get into it, and we'll come back for electricity. So today's number is 1. Today's is July 30th, 2025. So the number 1 in numerology signifies independence, confidence, a new beginning. It also represents an innovative and creative spirit. And it's associated with the zodiac signs Aries and Leo. And I just always give a reminder of how we get the numbers. I believe this is a Pythagorean reduction system. So you just add up all the numbers and the date, month, the day, the year. And then if you get 2 digits, like today, you add up all those digits. You get 19, you reduce it down. 1 plus 9 is 10. And then you reduce it further. 1 plus 0 is 1. And just a reminder again that this year, 2025, has a number 9. Symbolizes completion or the end of a cycle, transitioning to a new phase. It's connected to inner wisdom, spirituality. So I'm curious if anybody out there has found this number to be working at all in their lives now that we're about halfway through the year. Do you see anything coming to an end? You starting something new? Any sort of inner revelations, epiphanies, things like that? I haven't really. I know I'm getting more and more frustrated at my job, so that's probably going to be coming to an end soon, whether or not I like it. By my own doing, of course. I'm not like trying to blame anybody, but I don't know. Sometimes you just feel like you've outgrown something and it's time to move on. But you don't have anything to move on to, so we'll see. And I don't think I actually finished this part. So I never got a new quote of the day, so this is the same one if you were listening last time that we have. So we'll just go through it again. Learning is the beginning of wealth. Learning is the beginning of health. Learning is the beginning of spirituality. Searching and learning is where the miracle process all begins. And that is from Jim Rohn. And I just forgot to update it. I was going to at the very end of the presentation when I was done with all the other stuff, but I never went back to do it. So apologies, but it's a good quote. I still like it. Alright, so we're talking a little bit about what's going on in space right now for August. We've got a couple good things. So the summer triangle, that's been up, throughout all of summer, but in August it's much easier to see because it's higher up in the sky at better viewing times. It's just a fun one to look at. It's pretty easy to see. There's a cool planetary alignment happening, and then we have the Perseid meteor shower, and that is one of the best meteor showers of the year. So hopefully you can get out and see it. We've had some pretty bad weather overnight here lately, so I'm hoping to get out. But I'm usually asleep, by 10 o'clock anyway, so I'll probably miss it all. So first we'll do a little bit of a solar update. If you remember, we talked about the sun in one of our last episodes, and there was a huge solar prominence and a coronal hole that was just gigantic. And no major geomatic storms from either of those events. They're always monitored pretty closely. There was a CME, coronal mass ejection, that was predicted to hit Earth on July 27th, but it didn't. So there were no storms from that, no storms from the coronal hole. If you're watching, there's a picture on the screen from July 28th of the sun. So nothing unusual going on now, and no major disruptions from either of those huge events that were going on last month. Or I guess earlier this month. It's still July. I keep thinking it's August. Alright, so the summer triangle is kind of what it sounds like. There are 3 constellations, and the brightest stars of each of them make up this summer triangle. And these stars are all fairly easy to spot. You'll notice probably the summer triangle before you recognize the constellations. You'll just be these three bright stars up in the sky, and they are from Cygnus the Swan, we have Deneb, Lyra the Harp is Vega, and Aquila the Eagle is Altair. And I believe Vega is the brightest in the radio wavelength of all of the stars. Sirius is the brightest visually, and Vega is the brightest from radio. I think if you've ever seen the movie Contact, I believe that's where they're getting their signal from, and they get some strange signal back to Earth from somewhere out there, and I think they say it's coming from Vega. So this summer triangle is visible all summer, but in August here is kind of one of the better times to view it. If you're watching the screen, I don't know, you probably won't be able to see the outline of the constellations very well, but they're in green. The constellations themselves, Cygnus is pretty easy to see. Aquila I think is difficult. Obviously you get Altair, you get a few other ones. And the harp, Lyra, I mean, it doesn't really look like a harp. It looks more like kind of like a parallelogram with a triangle at the end. So, and that one's pretty visible, or pretty easy to pick out, I think. But certainly you can see those stars when you look up in the sky. If you see three bright stars, that's almost guaranteed to be the summer triangle. Alright, so this planetary alignment. Oh, looks like I didn't get a picture here either, dang it. Oh well. So, there's going to be, on August 11th, you're going to have Mercury, Venus, Jupiter, Saturn, Neptune, and Uranus are all going to be lined up on the kind of the eastern sky before sunrise. And they'll all be visible except Neptune and Uranus. You'll be able to, if you get a telescope, like a small telescope, maybe. So what I saw was high power binoculars, but I never got I couldn't find out what they meant by high power. So if you have any binoculars, you might give it a try. I know just recently, I think it was last month, Neptune was visible, I thought, with binoculars. So apologies, I don't have a picture either for that. I meant to do it, and I was looking for something good, so the credit that's on the screen is for something else. So this is just kind of a rendition of it from an app that I can click on here in a second. So this is what it's supposed to look like. So we've got Mercury way over on the left if you're watching. Venus and Jupiter are kind of close together, then Uranus, Neptune, and Saturn, and then there'll be a full-ish moon. So that might kind of obscure viewing of those dimmer planets. So this is from a site called starwalk.space, and they have this thing. Let's see if this works. So it's a Starwalk. It's an app that you can put on the phone. I haven't tried it. They got a couple, it looks like. Starwalk was the one that I was going to look for. Eclipse guide. That's kind of cool. Sorry, now I'm just going to start doing my own research here with you guys. So they've got something called Sky Tonight. So this is vitotechnology.com if you're interested. If you go to the Starwalk app, then you should be able to find that. Or Starwalk. What was it? I don't even know. Starwalk.space. And they have a link to Vito Technology. So just have a comparison of a couple of their apps. Looks like they've got just stuff where you can look at what is the sky going to look like. They'll show you the constellations. It looks like maybe you can take a picture with your phone, and then the app will tell you what's out there. Like it'll put together the constellations that it sees and tell you, kind of like outline them for you so you can see what's out there. So that's pretty cool. Let's see here. Interactive sky map. Point your device at the sky to see real-time positions of celestial objects. Travel through time to see positions of celestial bodies at any past or future date. Reality mode. Augmented reality mode. Or just reality mode. Night mode, astronomy calendar. Yeah, so this is pretty cool. So I don't know if it costs anything. I've never looked into it. I just saw it the other day when I was going through this. But yeah, that'd be kind of cool to have where you can just take a picture of the sky and it'll tell you what the constellations are out there. Because a lot of times that's the hardest thing to do. And if you get a star chart or a planisphere to take out there, the problem is that you can't read it in the dark. So you have to have a light with you. And the best way to do that, if you're going to have a light with you, if you're stargazing, is to make sure it's a red light so you don't ruin your night vision once your eyes have adjusted. So that's pretty cool. If you guys want to check that out. And no, I'm not getting any sort of payment or benefit from saying this or promoting this. I have no idea if it's any good. I just thought it was kind of cool. And I just really like this picture. That was the main reason, because I like their picture that they had here. So anyways, this is the alignment that's going to happen around August 11th. It'll happen over a few days, but I think it's not right before dawn, but a couple hours. So it's might be kind of difficult unless you're up already. But that'd be pretty cool to see that kind of alignment. The last time, we had all 8 planets aligning on April 8th, 2024. So just last year we had this during a solar eclipse. And the picture that I'm showing here, if you can see it, is a picture that I took with my camera. I've never really done astrophotography. I think it's kind of cool, but I don't have any of the equipment for it. So I just put a filter over the camera on my phone and just aimed it and took a picture, and that's what I got. And it's pretty good, I thought, for just kind of a slap together solar filter. So just like with your eyes, you don't want to be putting your aiming your camera at an eclipse or the sun without protection. I just used the you know how you can get the solar viewing glasses, like they look kind of like sunglasses. I mean, they're the paper ones, and I put that over the lens of my camera on my phone and just took a picture. So that happened last year. So we had all 8 planets aligning. The next 7 planet alignment is February 28th, 2028. So if you don't get this one coming up here in a few days or weeks, you can try again in 3 years. Alright, and then the Perseid meteor shower is coming up, and they originate in the constellation Perseid. Obviously, that's how they're all named. Whatever constellation it looks like they're coming from, that's where they get named from. That's how they get their name. So it's been going on since July 17th, and it'll go through August 23rd. But the peak is coming up on August 12th or 13th. So that's when you should have the best chance, sometimes up to 100 meteors per hour. And the best time is going to be after midnight. You're going to have sort of a full moon. This is about 84% full, so that will drown out a lot of the smaller meteors. So you might want to try getting out before that peak day, because the moon won't be as full. So yeah, you won't have peak meteors, but you'll have darker conditions, so you should be able to see better anyway. And this is something I always want to go out and do. Like, I kind of regret that I have to be in bed so early, because I have to get up at 4 o'clock for work on my work days. And then just after taking care of a kid all day, you're kind of ready for bed by 9:30 and 10 o'clock. So, especially in the summer here, it doesn't get dark until like 9:30 almost. So I might miss this one, but I love meteor showers. I'd love it if any of you, if you see them, if you take pictures. We've got a Facebook page for the interested reader, and you can post them there. So that'd be pretty cool. But yeah, if you can get out, see some meteors. I think meteors are one of the best things to watch in the sky. They're just so cool. So then here is where you'll be seeing Perseus if you look northeast. The easiest constellation that you're going to see, the one that probably everybody's going to know, is Cassiopeia. If you don't know that's what Cassiopeia is called, it looks like a W in the sky. So you're probably looking at it, you've probably seen it. Maybe you didn't know its name. And Perseid is just below Cassiopeia. I don't know, from the picture here, if you're looking, it kind of looks like a weird trapezoid body with a head and two arms. So it's a fairly large constellation, and probably about the only grouping of stars that you're going to see below Cassiopeia. So if you see any sort of conglomeration, it'll probably be Perseus. So essentially, if you're looking northeast around 11 midnight, that time frame, that's where Perseus is going to be, and you should be able to see the meteors there. Now, that's not the only place. I mean, you can see them looking any direction, but that's typically where you see most meteors originating from. So it's probably your best viewing location, but they could be anywhere. So the other constellations I think that are Andromeda's out there as a constellation, but that one I think is hard to distinguish what it is. Triangulum, that one I think is pretty noticeable just because it's 3 stars. It looks like a little tiny triangle. Summer Triangle looks huge if you're looking for that one. Triangulum is very small. And this screen, if you're watching, is from Sky and Telescope, and so they have a really good program where you can go and type in your location, the date, the time that you want to see, and it'll put it up on the screen like this. And I think they have like a circular, more like what you'd see as like a star chart. And theirs is really good. I don't know if you can. I guess if you have it on your phone, it'll probably work. They may have. I'm sure they have an app for your phone, but I always just use the website. But I really like Sky and Telescope for their night viewing program. All right, and this is a reminder of space weather. If you're interested in that, you have spaceweather.com, the NOAA Space Weather Prediction Center, Solar Dynamics Observatory, and the Solar Heliospheric Observatory. Those two are both done by NASA. NASA, NOAA, and then spaceweather.com is just a private party, which is pretty good. They have a lot of stuff kind of gathered at that website if you're interested in the sunspots, the solar flares, the coronal holes. Spaceweather.com has a lot of that on there. Alright, so this didn't turn out quite as good as I thought. If you're watching. Hopefully, maybe not even watching. So, we're going to talk about the pull of the invisible, magnetism, energy, and connection. I love magnetism and magnets. So we're going to get into some of the physics and some of the equations. We're not going to obviously derive them, but just so you have a little bit what we're talking about. So far we've talked about the solstice and the nature of light. So now we'll get on to magnetism. And again, I kind of did this out of order because we haven't really talked about electricity. You've probably heard me say that electricity and magnetism go together. That's why we have the word electromagnetism. And both of them are big components to the electric universe theory. And if you've been listening to me, you've heard me talk about that because it's my favorite theory as far as cosmology goes. So magnetism is an invisible force that really shapes the universe. We can't see it, but we can certainly feel it, and it is there. So we'll also talk about some of the other more spiritual connections at the end here. So if you'll recall, we have this thing called electromagnetic radiation when we talked about light. And again, we have that word electromagnetic because it's electricity and magnetism. They both kind of go together. So just as a reminder, we have this spectrum that goes all the way from gamma rays to radio waves. Very, very short wavelengths are gamma rays. Very long waves, radio waves. And then our visible light is just a very small portion of that. And remember, light, I just threw this in just as a reminder of kind of our wave theory, that light has this particle-wave duality where we have both particle like photons, and then it also behaves like a wave. So magnetism is a fundamental force, and it's linked to electricity, as we've said. That's how we get that word electromagnetism, and we'll see in some of the equations. Actually, I don't know if I got these two in there. How the two are related. So a moving electric field will cause a magnetic field. And that's typically, I think that's how we end up doing the equations for magnetism, is that we basically have a moving electric particle, and that moving electricity causes a magnetic field. And vice versa. If you move a magnetic field, I think you can get an electric field. I think. I should probably double check that before I said it. And then there's also a thing called where you have an intrinsic magnetic field, and elementary particles like electrons just have a magnetism built into them. So all of the all atoms, if you remember from chemistry class, I think it was, maybe we do it in physics, but atoms come out being charged. They can either be positive or negative charged usually. Sometimes they're neutral, if they're supposed to be neutral if your electrons balance your protons, but they can't have a charge if you've been ionized. So electrons have an intrinsic charge to them, so they can have this intrinsic magnetic field. And the standard unit of a magnetic field is called the Tesla. And next time, we'll talk about the Tesla's namesake, Nikola Tesla. And if you're watching, I'd be curious if anybody knows what that picture on the screen is from. One of my favorite cartoons growing up. So if you know what the screenshot up here is from, let me know. Tell me in the comments that you know what that was from. So again, I'm going to kind of end up, I really wanted to talk about Tesla when I started looking at magnetism because I really like him. So we'll probably do an episode on electricity after that. So everything's going to be all out of order and jumbled up, so I'm sorry, but that's just kind of how that's the random walk that I took. So, and you're following along with me, so thank you. Wandering the universe. Alright, so every magnet has a north and south pole, and opposite poles attract, and like poles repel. So there's just a couple examples here of, you've got some bar magnets, a horseshoe magnet, and then some iron filings to just kind of show where the field is. So electric fields are defined by placing a charged particle in an electric field and measuring the force on the particle. So we have this equation. The electric field E is the force of that field divided by Q, which is the charge of the particle that's in that field. So that's how we determine electric fields. Magnetic fields can't be defined that same way. You might think, okay, we'll just take the magnetic particle and put it in a magnetic field. Good theory, but that would require a magnetic monopole, which doesn't exist. So you can have an electric monopole that is just your single particle, like an electron. It's a single particle, it has an electric field. You can measure it. You can put it in an electric field, you can move it around. It's a single particle. But we don't have that same analog for a magnetic particle. There is no single particle. It requires two to have a magnetic field, north and a south, to have a magnetic field. So we have to find some other way to define a magnetic field. So what we're going to do is we're going to take an electrically charged particle and we're going to move it. And that's how we're going to get that magnetic field. So the magnitude of the field is going to be called, magnetic fields are defined with a B, electric fields are with an E. So we're going to take our magnetic field, the magnitude of it, and that is going to be found by taking the force of that field divided by the charge Q of the particle times the velocity of that particle. And that's just going to give us a magnitude. We don't have a direction for it yet. We get that by doing what's called a cross product. And so you'll take the force, and that's the QV quantity cross B, where your force, velocity, and magnetic field are all vectors. A cross product, it's not quite the same as a multiplication. That was pretty confusing when you start getting into physics and everything's written with. It looks like a multiplication sign. It looks like that cross sign for multiplication, but it's called a cross product, and it is not straight multiplication. So that's how you would find the magnetic field. It's just not quite the same as the electric field, and the two are related, and we'll get to that in a minute. So the two are related, here we go, through a series of equations called Maxwell's equations. And obviously, I'm not going to go through all the derivations of this, but in all these equations, if you're looking, the dot that's in between them, so we have like E dot dA, that's a dot product. Again, not a multiplication. We have cross products and dot products when we talk about these equations. So the first equation is Gauss's law for electricity, where you relate electric flux to electric charge. And then we have Gauss's law for magnetism, which relates magnetic flux to magnetic charge. And flux is just how much of a field is passing through a surface. And then we have Faraday's law, which relates an induced electric field to magnetic flux. And then we have the Ampere-Maxwell law, which relates magnetic field to the electric flux and the current. So that's how you you can relate these two together. And as you can see from Faraday's law and from Ampere-Maxwell, if you do something with the electric field, you're going to change the magnetic field, and vice versa. So these two fields are very much related, and this is why I don't understand why nobody really wants to put any thought into the electric universe theory, because we see electricity everywhere in space, and it's very often moving because the universe is expanding. We see that with redshifts. And if you have an electric field that's moving, you have magnetism, and you have all these charged particles in the form of plasma that are going to be interacting with this magnetic field and the electric field. And it's everywhere. Everything in space is a plasma. And we have electricity and magnetism everywhere, but nobody wants to use it. They stick with gravity. And to me, it's unfathomable why no one wants to look at the electric universe theory. I think maybe it's starting to come around now. But this isn't new. It's been around, I don't know, since like the 40s or 50s, maybe earlier. I mean, certainly when I was in school in 2000, I knew about it. I mean, that's 25 years ago, and even then I was like, this is the greatest thing ever. It's electricity and magnetism. This could solve all our problems. And then, man, the resistance you get from academia is just staggering. I couldn't believe it. So anyway, here we have our relation of electricity, magnetism through Maxwell's equations. And if you are thinking about getting into physics, if you are in physics, you will have to memorize those. And so Maxwell's equations can describe pretty much every electromagnetic phenomena. They can also be used to derive equations that we see, that we use for when we get into the wave theory with diffraction, reflection, interference. When you start describing things like that you'll need for telescopes, for optics, you'll be using Maxwell's equations in some form. You'll derive something from them. That is kind of the basis of all electricity and magnetism, are those four equations. And Earth has a magnetic field, as do most of our planets, and its interaction with the charged particles cause the auroras. I don't know if any of you have ever seen the Northern Lights or Southern Lights if you happen to be in the Southern Hemisphere. I never have. I know there have been times where they've been visible as far down as where I am. I'm in Iowa. But I never got to see them. It was one of those things, again, where you had to be up at like 2 or 3 in the morning to go look at them, and I'm just like, I mean, it's cool and all, but no thanks. And I used to live in Wisconsin, a little farther north, and I don't think we ever saw them as a kid. I remember my parents talking about them, like, it was going to be visible, but again, it's one of those things where it's so late at night, and as a kid, you're not going to be getting up at 2 o'clock in the morning to go look at the night lights, the night lights. So anyway, so here's some images on the screen. One is pretty cool it's looking at the South Pole from space, and you can see a ring of green glowing aura around it. So this is all caused by, usually when so we're in the path of the sun, it's kind of got a constant stream of particles, just blowing off into space. And those particles get sucked into our magnetic field, and they spiral through the atmosphere, and it's that spiraling motion that causes them to become ionized and glow these different colors. So that's how we know that there's a magnetic field there, or one of the ways. So kind of an interesting thing about Earth's magnetic field is you can kind of think of it as a bar magnet or this magnetic dipole. There's two parts to it. We've got a north pole and a south pole. But the north pole of this like bar magnet that you would have, the magnetic of this magnetic field, would be in the southern hemisphere, and the south pole of the magnetic field would be in the northern hemisphere. So it's the magnetic field is actually reversed from what we call north and south pole. And so how this happened is that the north pole of a compass, so a compass is also basically a bar magnet, just a little teeny tiny bar magnet. And the north pole of that compass will be attracted towards the Arctic. Oh, I had that backwards, the Antarctic. Oh, sorry. No, attracted toward the Arctic, which is the south pole of the Earth's magnet. So we know that it's the south pole. The magnetic, how do I say this? The magnetic field of Earth, the south pole, is at the physical north pole of the planet. And we know that because the magnetic field lines, you can see how they're, the particles will basically come into the planet at the north pole. And when you have a magnet, the magnetic field lines come into the south pole of that magnet. So magnetic south is actually points to the physical north pole. So when your compass is attracted toward the Arctic, that has to be the south pole, because remember we have opposites attract. So if the north pole of the compass, the little bar magnet compass, is being attracted to the Arctic, then that would mean that Earth's magnetic, bar magnet would have to have its south pole in the Arctic, because that compass north is being attracted to that location, and they have to be opposite charges. So I don't know I hope that makes sense. I just thought it was pretty fascinating that our magnetic field is actually flipped from what we call north and south, because it was just, I think it would just be we kind of got into this habit of calling the North Pole north. I mean, that's kind of physically, the top of the planet. So you're going to call that north. I didn't look up any of the dates or anything, but I would imagine that we were calling it north before we knew that there was a magnetic field. And then once we found out that there's a magnetic field, we find out that, oh, that's actually magnetic south is in the North Pole. So we were already stuck calling it the North Pole, though. But that's pretty interesting. I like that it was flipped, just because it's weird. So I hope that made sense. It took me a while. I had to read it a couple times when I was trying to figure it out. Like, North Pole of the compass is attracted toward the Arctic. So that means that magnetic south is in that north, the physical, geographical north. So most planets have magnetic fields, even if they're very weak. And we've talked about the sun's magnetic field and how it's responsible for sunspots and prominences. And stars, planets, black holes, galaxies, everything pretty much in space has a magnetic field. And that's what I was talking about. The electric universe theory uses magnetism to describe the universe. And this magnetism is everywhere. Everything has a magnetic field. And if you're moving, you're going to have an electric field. And everything is pretty much charged. There's a lot of plasma and ionized gas out there. Even the dust that's out there ends up getting charged. So it's all interacting, and it can all be described with the electric universe theory. So if you want to buy magnets, this is a pretty cool place that I found. I think I might actually have to go here and buy magnets. It's homesciencetools.com. And it didn't seem like it was super expensive. So they've got things like, so you can build a Gauss rifle, which I think is just shooting little magnetic balls. There's a strength of an electromagnet kit, so you can make your own electromagnet. Iron filings, because a lot of times I was reading about different experiments, and they said to just put some iron filings on a sheet of paper. I'm like, who has iron filings just sitting around the house? I mean, I don't. I never have. But here you can buy them for $3.50. You can get a tube of them, and then you can actually do these things where you can, because I would love to do that. Like, yeah, that'd be fun, but who has iron sitting around? Just some shavings of iron. But you can get bar magnets, you can get a compass, different types of bar magnets, horseshoe magnets, just magnetism kits. They got all sorts of stuff. Ring magnets, ferrofluid nanotechnology. And they're not too bad. I mean, these kits are like, $50 or less, it looks like, for the most part. So there's actually an experiment to do it, to make your own compass, which I'm going to try out later today. I should have done it now, but I do these recordings early in the morning, before I have to get everybody up and awake. And so maybe later on I'm going to try this thing where you make your own compass. But yes, this website's pretty cool. I think if you guys are interested in buying magnets, I found this was a good place to go. A lot of other places just had really like kind of basic, almost more like for very young children kits, which is fine. But I was interested in more like here's a giant horseshoe magnet for $9. I don't know, 8 inches, so maybe not giant, but So, and I haven't looked at the rest of their site. They've got all sorts of stuff that they've got. They've got chemistry, biology, earth space. I mean, they got tons of different stuff. So, microscopes. So this might be a fun place to go if you're looking for, STEM activities for anybody. Magic Penny. So yeah, take a look at that site, homesciencetools.com, if you're interested in STEM stuff. So some of these experiments you can try at home. Magnetic field mapping, that's where you take the iron filings, you put them on paper, you put a magnet underneath it, and you'll see the iron filings will all arrange into the magnetic field lines, so you can see where the magnetic field lines are. You can make this compass. So I think the way to do the compass was you take any sort of magnet that you have, like just a refrigerator magnet, and you rub a sewing needle on it a few times, and that's supposed to magnetize the needle. And then you can float it in a bowl of water using either like a cork, like you can put it in a piece of cork. That's what I had read, put it in a cork. Or you can lay it on a leaf. And I'm just going to do a leaf because I don't have cork either. Me without my cork. So I'm just going to get a leaf, you put it in the water, magnetize this needle a couple times on a refrigerator magnet, put the needle on the leaf, and it should orient itself properly. So I'm going to try it out. Magnetic repulsion attraction is just sort of not really an experiment. It's just what anybody does with two magnets is you put them together and you can feel them attract, or you flip them around to the light poles and you feel the repulsion, which is always fun. Invisible force field, you just put something on your table like a paper clip or something, put the magnet underneath the table, and then try to move the magnet or the paper clip around the table using the magnets underneath. And then you can, I don't know, see who can move it across the finish line the fastest or something. I mean, however you want to do that, but you need magnets first. So if you want to go to that one site and get magnets, if you don't have them already. All right, so I think that is it for the science of magnetism. So if you have any questions about that, let me know. We are going to move on to spiritual magnetism. So like we just talked about, magnetic fields are invisible, but they definitely have noticeable effects. They definitely affect us. They have effects on the world. They affect us. And we all have a magnetic field too. The heart and brain produce a magnetic field. So when you go to get an MEG, a magnetoencephalograph, that's measuring the magnetic field of your brain. And an MCG, the magnetocardiograph, is measuring the magnetic field of the heart. And the heart is much stronger than the brain when it comes to magnetic fields. And magnetic energy kind of symbolizes intuition or inner guidance. You have a pull toward a passion or a purpose. You can have connections between people if you ever kind of just felt drawn to somebody, or just kind of repelled by them, like you just don't want to be around them. There's nothing noticeable, there's nothing seen between you and that person, but it's often been said that if you're not at the same vibration, if you don't have the same sort of energy field, the aura, that's what actually you're feeling when you kind of feel either attracted to someone or not. In this case, you'd probably be attracted to someone with the same vibration as you instead of opposite. But we do have the saying, opposites attract. And we also will say that somebody maybe has a magnetic personality because she just draws everybody to her. And so magnetism, these phrases come up in our kind of daily language because we actually do have this feeling that there's something out there that pulls us toward another person. And it all kind of comes from this idea of magnetism. So some of the questions that I kind of like to think about when I'm talking about this subject are, what am I drawn to? Intellectually, emotionally, spiritually? Where do you feel like just an unseen pull towards something? And similarly, where do you feel repelled by something? Or where does something feel like it just isn't right? It's energetically like it's out of sync. It's just draining to be doing something or being around somebody. And am I aligned with my inner compass or magnetized by distraction? And there's this other podcaster that I listen to, and she sends out these kind of daily motivational things. And one of them was about, just recently, about leading with your inner compass. You're kind of listening to your intuition and that inner guidance system about what to do, where to go, what to say. Rather than getting tied up with the what should I be doing, what should I be saying, just listen to that inner compass. Let that guide you. So magnetism reminds us that just because something is invisible doesn't mean it's not real or powerful. Because magnetic fields can be extremely powerful, but you can't see them. You'll never be able to see them, but they're there. And so many things like that I think in our lives are like that, where you can't see the spiritual force, you can't see the attraction between two people, but you can feel it. It's there. So just kind of as a reminder, kind of tune into these invisible forces around you. So here's some sky watching resources. Again, we've got Sky and Telescope. They have an interactive sky chart. You've got space.com, you've got spaceweather.com. And I think that's probably it I've got for you. Again, I've got my book, Astronomy for the Soul, ebook, if you're interested. And you can find the Interested Reader in all the usual places. And I think that's all I got for you guys. So as you go about your day, just keep in mind that we are all kind of living in an electric field, a magnetic field. Just kind of pay attention to that inner compass and see where you're pulled. See what's guiding you. Kind of tune into what's leading you and where, and see if it aligns with your inner compass. And if you are of the mind, you can share it in our Facebook group page. You can email me. I'm on Instagram. Go to the website. You can sign up for a newsletter. I've got a couple things that I'm going to be posting in the Facebook page. They're just kind of simple. Like there's just a sky watching chart. It's not really a chart. It's just kind of a reminder of some things to go look at in August here. Just a little printout. There's a map of the summer triangle. Just a few things to go look at tonight. Just a reminder to get outside and look at the sky, look up. So I think that's all I have for you guys. If you have any questions, if there's a topic that you want to hear about, let me know. You can email me. There's a contact form on the website. I keep forgetting to check to make sure it's actually like accessible. It might be kind of in a weird hidden spot that I think is accessible, but it might not be. But email's a good way, or you can leave comments. Go to Facebook page. I'd love to hear from you guys. So let me know what's going on, and I will see you next time. Thanks, guys. Bye. I hope you enjoyed this episode and are inspired to question and investigate the world around you. Let me know what you're thinking about. You can contact me through the website, theinterestedreader.com, send me an email at sarah@theinterestedreader.com, or join the Interested Reader group on Facebook. I'll see you at some later time T, where T is greater than T naught, and T naught is equal to now. Thanks for being an interested reader, and I'll see you next time.